Our next speaker will give us a presentation to begin to showcase one of the ways in which the open citations that are part of Crossref's record has been made use of and, well, put to use. Here I will introduce Nicholas Bailey, who is a part of Royal Society of Chemistry, one of the publishers who have made their citations open. He's a web analytics expert there and has much to say about measuring digital products, machine learning, and the potential of data science to contribute to positive social outcomes. Nicholas's talk today will be about what data science tells us about the social challenges in scholarly publishing.
Thank you. Hi everyone, it's a pleasure to be here. My name is Nicholas Bailey, as Jennifer said. I'm a part of the data science team at the Royal Society of Chemistry. And I've been invited here to talk to you a bit about what we do. And in particular, I'm going to tell you about a recent project we're engaged in, which is to do with social challenges in scholarly publishing and throw some light on how data science can help with that sort of thing and why data scientists would be particularly interested to help with that sort of thing. I'm also going to try to give you a bit of a broad overview of what we do. As before, this can only be a 15-minute presentation, so there's lots I won't be able to cover. But I will be around. But first of all, there'll be questions at the end of the talk. I'll also be around for the rest of the day and tomorrow and Thursday. So please do approach me if you want to talk about this in any more detail. So depending on where you work and what you do, you may or may not know very much about the Royal Society of Chemistry. We are, first and foremost, a charity with a Royal Charter, and the Royal Charter says that we will advance the chemical sciences, which means that we are not-for-profit, and any surplus income that we generate goes back into the chemical sciences through our charitable activities. We are also a learned society, as the name suggests. If you are within the chemical sciences, you can become a member, and if you are a practicing chemist, you can become a chartered chemist through us, which is an indication of excellence as a scientist. We also are a publisher, and this is the way that we interact with Crossref and why we're so grateful for the excellent work they do. As well as being a publisher, we produce resources and tools to help the chemical science community, and this is really to do with advancing the chemical sciences right across the board. So there are tools for chemistry teachers for inspiring the next generation of chemists. There are also tools for practicing chemists to discover the substances or chemicals they might be looking for. Prospective drug molecules, and material scientists could use tools like ChemSpider, which is a database of molecules. So that's the context. So within that context, I'm going to talk to you about a project we did recently and what we do overall. The project we did recently was to do with gender biases within the scholarly publishing pipeline. In working on this, we've come across two main points around what data science shows us about the social challenges in scholarly publishing. And these are broadly that, first of all, these are best done in collaboration. We do a lot of collaboration with other publishers and other organizations who might not be publishers. And what we found through that is that there are a lot of shared issues that we can attack together, and it's a lot easier to come to good solutions that way. The other thing is that attempting to find solutions or remedies to social challenges is not always a charitable exercise or a heroic exercise. In the case of data science, especially when you're talking about biases, it's just necessary quality assurance. Because if you're producing predictive or descriptive models, you want to be absolutely certain what biases might be getting baked in. Finally, what I'm going to say at the end of this talk is that if you see some of this and you think, yeah, my organization could really benefit from a data science team, you might be in luck. You may already have one that you don't know about, and I'll explain what I mean later. So here we are, the data science team. We have three main things that we work on, which are all interlinked. The first is to develop new ways of handling chemical science information. This has to do with statistics and machine learning, Can we apply the sorts of things that Amazon might use to recommend a book in order to recommend a molecule, or that sort of thing? We also try and find innovative ways to apply statistics and machine learning, which may be finding new algorithms, new ways of doing within machine learning, or it might be taking innovations from other sectors and trying to apply those to scholarly publishing or to chemistry in a way that benefits our members or scholarly publishing. Throughout our work, our main aim is to make the Royal Society of Chemistry increasingly data-informed. So the decisions that are made at the individual or the team level, or at the departmental or organizational level, are ideally increasingly informed with robust statistical data. So here's an example. We're really lucky at the Royal Society of Chemistry to have an inclusion and diversity team. And through the course of their work, they asked us to look into gender biases in the publishing pipeline. I was trying to explain my talk to somebody earlier today, and they said, how on earth can you do that? How do you detect that? Where's the data going to come from? And the answer is that it's very, very difficult. There are two main things that you need in order to do this kind of research. You need to know the gender of the different actors, the people within the publishing pipeline. So those in the author community, those people who are submitting articles on particular topics, those people who are reviewing the articles, and those people who are reacting to the articles, who are citing them or downloading them or tweeting about them. And the next thing you need to be able to do is measure actually all of those actions as well. So once you know or you're able to produce a reasonable estimate of the gender of an author, for example, and you have a really accurate idea of how their paper was received, you can start to look for statistical links between those things. So here's a simplified publishing pipeline. So to approach this problem, what we did was sketch out something like this and start to produce questions. So you have the author community, which is bubbling away. You have new authors coming in all the time. You have other authors retiring. And so the ratios of all kinds within different fields, gender ratios, and lots of other things are changing all the time. Some of those will submit articles. And there might be some effect around the gender of scientists and how often they submit papers, or what kinds of papers they submit. That would be interesting to know about if that existed. Once papers are submitted, they get reviewed. It's really important to know, do peer reviewers, whose only job is to check whether the science is valid and ethical and all of those sorts of things, whether they are at all influenced by the gender, by their own gender, or by the gender of the authors they're reviewing, or any of those sorts of things. We would hope not, but these are the sorts of things we would need to look at. And finally, does the gender of an author or the gender of a person reacting to a paper affect how a paper is received in the community? So, as I say, there are two halves to this problem. The first thing we did was to bring together absolutely all the data we had available to us about how a paper is received from the moment it's submitted. So, all of the great stuff that Crossref has about around the research nexus, which Jennifer was talking about earlier, including Crossref event data, which we're starting to integrate with the system. All the stuff that we have access to ourselves, but we don't yet share. It's important to reiterate at this point that we are for open citations, and we have made our citations open. We're increasingly making data we have available open in a collaborative way, but not all of it necessarily is open. So there are things around peer review responses that we have access to that need to be associated with documents. And there's a vast amount of data about how people interact with articles on our websites. And we link all of this together in a database. We use MongoDB as it happens, but that's not necessarily important. And we can take data from there and analyze it. So we can actually get a really clear idea of the actions taking place around an article. But then there's an even harder step, which is to look at the gender of primarily the authors of the articles, because It's the genders of the authors of a published article and the genders of the authors who are citing those articles in their papers that will give you most of your information about how research is being built upon in the community. How do you do this? Well, this is extremely difficult because actually, as a publisher, you don't need to know the gender of an author. What is important about the article is something entirely separate. And because you don't need to know, because of data protection laws, you generally won't know. So the British government has done similar studies to this in other areas, and what they have done for looking at genders around people filing patents is to use a data set like this, where you have a huge number of records about people saying what their name was and what their gender was. And this allows you to take a frequentist approach and say, if 97 out of 100 people called Troy, that ratio, there's probably more than 100 people called Troy in the data set, are male, then let's say it's 97% likely that a person called Troy is male. Now, there are obvious shortcomings in this approach. Not all names are gendered. Also, this data only contains names from the UK and the US, so this is a limited pool of names we can use. However, it does allow us to do interesting things like notice what names are very difficult to assign a gender to. If we have trouble assigning a gender to a name, it's likely that peer reviewers also will have trouble assigning a gender to a name. Which means that we can study papers by women in research groups led by women, papers by men in research groups led by men, and so on. But we can also study papers by people whose gender we have trouble guessing, and a peer reviewer would probably have trouble guessing as well. Now, this isn't all about peer review, but that's the sort of thing we can work on. So, using this kind of approach, we can make a cutoff and say, if someone is a certain percentage more likely to be of a certain gender, we'll use that in the data set, and we can start to use statistical techniques to work out whether there are relationships between the gender of a person and how they interact with the scholarly community. Now, Bayesian belief networks are one tool for doing this. This is not the only tool we use, but it's a really nice tool for illustrating the sorts of thing we're looking at because they can be used to make these nice influence diagrams. So for example, so in Bayesian statistics, the principle is, if you know a certain fact, a piece of data, does it inform your ideas about the likelihood of another thing being true? So, if we know that an article is open access or not, does that allow us to make a better guess at what journal the article is published in? Yes, of course it does. If we know what journal the article is published in, it allows us to make a much better guess at what type of article it is. Is it a review or a communication or whatever? These are the ones that are obvious and intuitive. So what does a statistical analysis show us is true between variables we can't necessarily obviously see the relationship between? So does the gender of the leader of a research group affect what papers that research group will cite? In other words, if I know that the research group is led by a man, for any given citation, do I have a better chance of guessing whether the paper being cited was by a research group led by a man or a woman? Or within a 2-minute warning? Or perhaps not the leader of the research group, perhaps the first author on the paper. And this allows us to, using something like Bayesian belief networks, we can start to see what things are and are not related, and we can identify those things that should not be related but clearly are, and take action on those. Now, we have a report coming out in Q1 of next year that sort of unveils, if you like, what we found. This illustration here is just to show you how one would work, and that's not to say that there necessarily is a link between those things. But suffice to say that if we hadn't found any interesting gender-related effects, we wouldn't be publishing a report. So please do, please do look out for that. The reason you might want to do this as a data science team, obviously, inequality is bad for everyone. It's bad for all of us, it's bad for science. But also, as a data scientist, gender inequality is a bias. And biases break models. And here's a good example. So Google, a leader in artificial intelligence, as we all know, produced a model which would take data provided by users in order to try to show them more relevant advertising on the websites they visit. If you go to Google's, or rather, in 2015, or I think the data was from 2013 even, if you went to this page and you indicated that you were female, then you were much less likely to see ads for jobs paying more than $200,000. Now, this is a company who, in most cases, really knows what it's doing with artificial intelligence, producing a system intended to help people even by stopping them seeing irrelevant ads, but in fact producing a system that is complicit in prolonging social problems that shouldn't exist. So within data science, we don't just want to do this stuff because it is ethically or morally right. It's also because you can't take your models seriously if you don't know all the biases in there. Now, I don't have time to tell you about all the other stuff we work on as a data science team, but what I will say is that key to it is collaboration. And we were a founding member of a group of publishers who come together to talk about these sorts of social issues in scholarly publishing. So gender biases, but also piracy. Also the generalized use of impact factor to measure things that maybe it wasn't designed to measure. And we work with all of these people, and the more we work with them, the more inspired we are to work together and to come up with good solutions. So if anybody would like to talk more about any of this, I'd be really keen, because collaboration really is key to solving these things. Some things of note are this system, which is called ChemListem, which is a competition, a system we developed that wins international competitions for pulling named entities out of text. So, for example, it can list all the chemicals in an article, a chemical science article. This allows us to draw out implicit links between articles that might not be made clear in the metadata. And the technology for that is based on neural networks. We've developed very powerful things that aren't based on chemical science knowledge, but are trained pretty much from the ground up. So that sort of technology can be applied to things outside of chemistry as well. If there's something that needs to be pulled out of text, that sort of technology can be applied. We also have made that open source and shared it with everyone. So we really are looking to collaborate, and we do work on a broad range of things that I wish I could cover with you today. Final thoughts I'll leave you with are, if you think your organization would benefit from a data science team, you may already have one. And what I mean by that is, I've heard a lot of stories about organizations who don't have a data science team, who set out to get one, and then suddenly realized that they had all of these people within their organization already who had those skills. Now, data scientists are not famously extrovert people. We won't necessarily come forward, but if you think this stuff looks good, you should take a serious look within your organization for the people who can do this thing, because they probably are there. I've already said that gender inequality is bad for everyone, but actually, another way we've been thinking about it is as a bias. And there are a lot of these social problems that are important to at least know about before you can make good models. We will release that report I was talking about in Q1 of next year. And in all of the work we do, collaboration and discussion is absolutely key. So I'll be around for the rest of the day, and tomorrow and on Thursday, and I'd love to speak to any of you about this in more detail. Thanks.
Thank you, Nicholas. I mean, I think this particular example is extremely potent for me. As I reference back to that earlier conversation about the Open Scholarly Map and what are some of the different sets of metadata when spun together could be made useful for a different set of use cases, such as discoverability, such as research integrity and reproducibility. One of the key other use cases that we didn't really get into is how publishers may find the consumption of the metadata of use to themselves. And here we see that the data science team within Royal Society of Chemistry have used it not only to expand on the types of services that they provide with ChemListem, but also to improve the publishing process themselves, right? This look at gender bias that may be implicit within their publishing editorial pipeline, et cetera. So I think the two talks tie together very well, the initiative for open citations as well as how the Royal Society of Chemistry is using it. We have a little bit of time for questions. Any questions for Nicholas? Yes, please.
I applaud the openness of the organization and what you're doing without reservation. Could you speculate, however, on what it is about the structure and operations of Royal Society of Chemistry that allows it to be and encourages it to be so open compared to, say, another society of chemistry that is also a publisher that may not yet be at that level of openness?
I'm sure I don't know who you're talking about, but so the key thing is that, well, the two key things, which I mentioned right at the beginning of my presentation. Yes, yeah. I'll come in again. No, the two key things are that we have a royal charter on which the entire organization is based. We have governance elected from our membership to ensure that we are, as an organization, acting for the benefit and the advancement of chemical sciences, which this plainly is a part of. The second thing is that we are a charitable organization, and not everything we do has to confer a competitive advantage. It only has to benefit science. So we have those advantages in this arena, I would say. I think there are some laudable people at the Royal Society of Chemistry who push for this sort of thing, but broadly it's because the entire purpose of our organization is to advance science, and gender inequality, among lots of other things, is bad for science. Does that answer your question?
It's a start.
Yes, yeah. I can't speak for other organizations.
Any questions about the data science of the use of citations, about ChemListem and or the gender studies? About starting a data science team within your organization? Who has one, actually?
I think that would be really good to know. Who has one that they've only got in the last 2 years? Right. Two. Okay. And that's a big publisher. Yeah.
Well, I'm from the Bay Area, and they say to have a joke that a data scientist is a statistician who doesn't have a job or has found a job in industry.
That's absolutely true. It is a joke, because why do you need another name for the job? But essentially, what data scientists do is statistics. So that's an interesting point. If any of you think of a question that you have not thought to ask now, but you suddenly think of as soon as you walk away, please, as I say and as I keep reiterating, come and talk to me, and I'm happy to go into more depth about this sort of stuff. Thank you.